PSIM iHill.
Okay.
This doesn't look like the same folder that. I thought I got rid of some of these. Okay. This is how you do this, alright? So in the PSIM DLL projects folder, there is a base DLL
Okay.
zip file. Use the zip file when you want to make your new DLL block.
Practice and shit.
Yeah.
Okay.
Anything. Anytime you need to make a new one, use the zip file and unzip it and then reconfigure it from there. Because for some reason, if you take the folder and you copy it, and then you use that one, what happens is that for some reason the different files become linked to each other. And you change one and it changes the other one because it doesn't discern. There's other things that are happening with Visual Studio that link everything together, and then if you change one, you end up with a problem. You can't just copy a folder and then expect the project to change. Alright, so what we're going to do is we're going to say tutorial 1, 1, 2. Okay. So we'll copy this.
But you say you can't do that.
The zip file.
Oh, a zip file. Okay. If it's
inside of something encapsulated, it's not going to affect it.
Okay.
Now what I'm going to do is I'm going to extract this here. Okay. Cool. So there it is. Alright. Alright, let's open it now. Okay. Visual Studio. Okay. First thing you want to do is you want to enable debugging. So you right click here, go to properties. Okay. You go to debugging. And you're going to make the path. And you're going to go to the G drive here where we are. We're going to go to PSIM. Okay.
What is this doing to the?
We're going to link this DLL to PSIM. So when we say debug, it's going to open up an instance of PSIM, link it to the process, and then when we put breakpoints in our code, we can run the PSIM simulation and it'll break at the appropriate points in the code so that we can debug it. We'll see all the variables and everything. You see similar stuff when you're doing things like MPLab or Logic Works, right? You know, when you see your debug output of your of whatever, it's the same thing. But you can. This is real stuff. So PSIM here, applications. We're going to link it to PSIM. So now PSIM is here in the debug command. Okay. Another thing that you want to know is basically where is this going? Output directory. What is it? So it's going to tutorial 1 PSIM base DL debug. So if I compile this, so let's go look in. So here I am, tutorial 1 base DLL. Alright. So there's no folder named debug, right? What if I build it? Build solution.
It goes there.
Well, let's check. There should be a folder named debug, and then there should be a DLL file here. they put it here.
Outside.
Outside of it. Alright, it's in tutorial 1.
Nice.
So for some reason, yeah, these are the kind of things that if you figure out how to fix Visual Studio a little bit better, then let me know. I get it to work sometimes, and sometimes I don't. So I don't question it. If it compiled and gave me a DLL, I'm super happy about it. All right.
Just find where it is.
So the main piece of code is right here. Simple block CPP. Okay. You put your variables here and instruct my data. And then when you want to access them during the simulation, you put my data with the arrow, and then you pull out your things here. So pointer. Okay. So let's just make it really simple file here. What we want to do is you have these variables here. Okay, t is the time in the simulation. Delt is the change in time per time step. So let's say that I went to PSIM and I made my simulation profile say my time step is 1 second. You know, then every simulation step, my first t is going to be 1 or 0, I think. 0. Next t is going to be 1. Next t is going to be 2. My next t is going to be 3. Delta is going to be 1. Okay. So let's output something. We can access the output pins here. 0, right? So let's say out 0. Okay. Is equal to so what's
Like, is it like a value, or is it like a instruction? The output.
well, what's the
Were we using 22 and 23 last time for the registers? It's just different.
Yeah.
so what's a 60 hertz sine wave look like?
It's like
120 pi, is that the frequency?
so 1 over
2 pi
2 pi
f.
f.
Omega naught t is going to be
2 times 60. So 120 pi.
120 pi, right?
Yeah.
Okay, so let's make a 60 hertz sine wave.
Okay.
Okay, out is going to be
1 over
169.7 times, because that's going to be the 120 volts RMS, right?
Okay.
Times sine of 120 times 3.1415 whatever times
Time.
It doesn't have just a variable PI, like pre-programmed.
you might.
Okay.
That's pretty accurate.
Okay.
All right. So let's see. I commented out. Forgot. Okay. This is just from my old program, so. So let's go. You press local Windows debugger. Would you like to build it? Yes. Alright. Opens PSIM. Okay.
And you create your box, your block.
So, there's the elements. Other function
Simple block or C block,
general DLL block. Okay.
and then one output.
What was it? You said general DLL block?
Yeah.
Okay.
There was no output, right? Or input?
One output, right? No input.
No input.
I'm not using it, right? Okay.
So you're gonna put that DLL.
Simple block DLL, right? Oh,
Set that 64
I forgot to
32.
Forgot to do it on 64. So we'll go stop. Okay. Yeah. So we need to do it in 64 now.
64 probably.
Okay.
Hmm.
Local Windows debugger. Do it again. Yes.
Good catch.
So it does it in 32 automatically.
I think maybe C block. Is it? Maybe it's just like the C block block of code that they made. Does it in 32. I don't know if, or maybe Visual Studio itself defaults to it.
That's because it's looking for that file.
It's outside the.
Yeah, it's not in the right.
Oh.
So now we have to fix that. Yeah, that's the problem. I remembered what it was.
It's where it is now.
Well, let's try it. Let's just try building. Read information. Let's see where it went. Didn't go there.
On the outside.
I don't see it here either.
Can you just
Oh,
move
it's
it?
in 64 DLL.
So if it builds it from like whatever folder, can you just
Where's your DLL?
maybe outside that?
It didn't send it to the right place. Output file, output directory, target name, target. Times 64, debug, simple block DL. So that's where it should be.
64.
Oh, there it is. Yeah, there it is. Now, is that where the program was looking for it?
No.
I think so. Times 64, debug. Yeah.
Is it?
This should be the platform, times 64. That should be the. this is
Oh,
output.
intermediate
Well, yeah,
directory
can
is
you
what we're
change it?
looking for that.
Configuration, debug, platform times 64. Solution directory is the base directory. Okay. Now this should work.
Hmm.
Go here, we go to our tutorial 1, base DLL, 64 debug, where it is, open the DLL, you're there. Number of write nodes, which is the output nodes, 1. Okay, looking good. Alright, so let's put a voltage here. Simulate, simulation control. The simulation control here. Total time 0.01 seconds with this no time step thing. Looks good. We run the simulation.
Okay.
Let's increase the time. 1 second. So we just
Wow.
program that in, right?
Using from Visual, so the PSIM took the Visual Studio's
Program
program
and use it for this.
Yes,
Okay. So that's the very basics of this, okay?
Sure.
All right. That's as basic as it gets.
That's pretty cool though. It's just like one box.
Yeah. It's pretty awesome.
You can do a lot of stuff in that one box. You
Yeah.
can do everything that you can do in C++ in that one box.
That's why it's 15 grand.
So if you take a look at the board,
Have a lot of boxes.
we have a lot of boxes to make.
Wow. Nice.
Does that make sense to you guys?
Yeah.
In
Oh,
a
yeah.
nutshell, for the big picture.
Lots and lots of boxes.
Alright.
Take a couple screenshots. Alright.
Is this the right sine wave? Let's see.
The frequency is so high.
0.016, which is randomly.
Okay, so this code is going to be whether or not the water heater is available.
Well, this is just my. I mean, like I'm just making this up as I go.
Okay,
But,
yeah,
I know, I was just putting that on there because I wasn't recording before I said that.
yeah, just be. Oh. One. So let's make this update every.
So it's 15 minutes.
I mean, how much would it bog the system down, like if we had it update every 1 minute? Would that be really, like, would that make it run really slow? The simulation?
Hold on. Every 100 time steps. That make sense to you?
What's that mean, 100 times a day?
No, I mean, it's, okay, so t divided by delta is going to be 1 every time step, right? It's going to be 1, 2, 3, 4, 5. So every time the time step, every loop is going to be another integer, right? If I had this update every t over del, it would update every time step to the next. And then this needs to be modulo 96, so that it repeats, right? And we can change this to make it so that's every 15 minutes or whatever, based on the time step. Okay. Five errors. Oh, yeah. So, of course, my data. About that. This is a C++ thing. Oh. T-log. Oh. That's because this is using it.
Where's the command that tells it to write to a data file? Is there one?
Let's just close that for now. What? Command to write to a data file.
Or is
You're
it?
gonna write one.
Okay. Fair enough.
What? Oh. My goodness, my sorry, my C programming is the rest of the node. Oh, not my data. Oh, data. Yeah. Data. This operand has double. Where's this? 44. Oops. Time? 75. Time.h. Works now. Alright, so
Is that library available in regular C or just C++?
it's available everywhere.
Okay.
That's like in standard library. Okay.
Okay.
Elements, other. So, are you guys learning from this?
Yeah.
It's pretty cool though.
Okay.
It's
Alright, so now we have two output nodes here, right? Oh,
Where do you
I forgot to open the thing.
where are you getting the file?
Simple block here.
It says or the data.
What?
Where are you getting it?
I've just randomly generated it just
Oh,
now,
okay.
right?
Yeah.
Okay, let's see if it works.
I think so. Well, like his last season.
Yeah, he did 20 years ago. Like, it's just like something did 20 this year.
All the same team.
Yeah, a water heater turned on randomly.
Hmm.
Let's change the simulation step.
Are these yours?
Nope, those.
1 second. Let's see if it works.
The reason he decided to put them here. Why?
I don't know why she keeps getting stuck.
I don't know why. It's just after a while she put them outside. And it's just why it's weird.
Oh, they don't die. They're stuck in this, dude. They're so hard to kill.
So random water heater from 1 to 96 turned on.
Right.
Well,
They're full of water.
but it's not always going to look like a nice, clean, square wave like that, right?
What do you mean? On, off.
You don't need to like.
That's what it is.
I see like
I mean, there's nothing else, like it doesn't, you know, draw more power as it turns on or whatever. Like as it's powering up.
Yeah, that's why they call cycles. What is it?
what time you're right.
They're
Okay.
super like hardy plants.